Hello and welcome to this video for Chemistry 20. This is Miss Simpson. This is the acid-base second lesson where we are going to talk about the difference between strong and weak acids and bases. So we talked about an introduction of acids and bases in the last video, and we looked at how acids again are substances that react in water to form hydronium, and bases are substances that either dissociate into hydroxide or react with water to form hydroxide. So when we're talking about acids and bases, their strength or how acidic or basic they are depends on two things. First of all, the concentration of the solution. Obviously, the more concentrated it is, the more acidic or basic it's going to be, since it's based on the concentration of those ions and how many ions they're producing. Second is the identity of the acid and base. Some acids and bases are just considered strong acids and bases, and some are just considered weak. So we're going to talk about those, how to identify if they're strong or weak, and then again the properties of them. So starting with acids, a strong acid is going to 100% ionize in water. So that means all of the acid is going to form hydronium ions and the anion. Now why that's important, so when I have my acid and it's reacting with water, remember what the acid is doing is it is donating the hydrogen from the acid to the water to form hydronium and the anion. Now, later on, we're going to get into pH calculations, and pH calculations are going to involve the concentration of the hydronium ion that the acid produces. So if it's a strong acid, the concentration of the hydronium ion is going to equal the concentration of the acid. I'm going to write SA for strong acid, okay? If I have a strong acid, 100% of it is forming hydronium. Okay, so we can say for sure then that the concentration of the hydronium ion is the concentration of the strong acid. Now, what that means is some of the other properties of strong acids is that they are more conductive. They're going to conduct electricity really strongly, and they're going to react really vigorously with metals. So remember in yesterday's video, we talked about how when you take a metal and put it in a solution, if bubbles are generated, those are hydrogen gas bubbles, that indicates that you have an acid. So the reaction that the acid has is going to be more vigorous if it's strong. If it's weak, it'll be only like a slow generation of bubbles. This will be very vigorous, okay? Also, your pH is going to be much less than 7. 7 is neutral. Everything below 7 is an acid, but the closer you get to 0, the stronger the acid becomes. And in fact, you can actually go beyond 0 and get into negative pHs. Now, these are the 6 strong acids, okay? They are given on your periodic table. If you have a Chem 30 data booklet, they are listed in the acid section of the data booklet, the top 6 on the data booklet. But for my Chem 20 students, we have just this list of them on their data booklet to show that these are the strong acids, okay? So if you have, again, I tell you have hydrochloric acid, it's on the list, it's a strong acid, all right? So you don't have to memorize them. They are given to you on your periodic table. But just know again, if your acid is one of these 6, it is a strong acid, okay? Now, if it is not on that list, it is therefore a weak acid. Now, weak acids do not 100% ionize. So what that means is the concentration of the hydronium ion is much less than the concentration of the acid. Okay, so if you were to compare the two concentrations, it would be much, much, much less. Only a small portion of the acid. Now, this is an example of a weak acid. This is acetic acid. It's not in the list of strong acids. It's still donating its hydrogen to make hydronium, but only very slightly is that process happening. Sometimes you'll even see these reactions drawn with equilibrium arrows to show that it's not a full forward process. It's not fully reacting. Okay? Now, weak acids, again, are all other acids that are not in that list of 6 strong acids. Again, we recognize an acid as starting with hydrogen, bonded to an anion, with a couple of exceptions like acetic acid, where it's an organic acid. Any polyatomic ion that has COO in it, the H is at the end because the H is bonding to the O of the COO, so it's just showing the bonding order of the elements like we talked about in the bonding unit. Okay, so that's why the H is written at the end, but it still is an acid when it has a hydrogen at the end. Okay. Weak acids are going to only conduct electricity very weakly, so only slightly. And like I said, they're going to react very gently with metals. So they will still produce bubbles of hydrogen gas, but only very slightly will those bubbles be generated. Okay? Their pH will also only be slightly less than 7, whereas a strong acid was much less than 7. Okay? So those are your acids. Now we'll get into the bases. A strong base, again, is going to 100% ionize in water. All ionic hydroxides, which yesterday we also defined as Arrhenius bases, the original Arrhenius base, an ionic hydroxide, okay? It is going to 100% ionize into its ions. So for example, if I have sodium hydroxide, I don't react Arrhenius bases or strong bases with water. I just simply dissociate them into their ions, okay? Now the concentration of the hydroxide ions are going to depend on how many hydroxide ions are formed. Because I balance my dissociation equations, I am going to be looking for the concentration of the hydroxide ions, and given the concentration of the base, if it's asking me to calculate pH, for example. And so we need to take the concentration of our given, the sodium hydroxide, and multiply by wanted over given, like we did in the solutions unit, to find the concentration of the hydroxide ions, which we'll learn more how to do when we get into the pH calculations. Okay? Now, the pH of a strong base is much greater than 7. Everything above 7 is a base, but when you get closer to 14, and you can again go beyond even to 15, then it is a strong, strong base. Okay? Now, all ionic hydroxides, again, if it's an ionic compound with the hydroxide ion, so in other words, a metal, if you have a metal bonded to hydroxide, okay, it is a strong base. Every other base is weak. And the other bases that we talked about yesterday that are considered weak bases are the modified Arrhenius bases. Okay, so these are things like ammonia, which you just have to memorize that ammonia is a weak base, and your anions. Remember yesterday we talked about how anions, negatively charged ions, can also act as a modified Arrhenius base, and the modified Arrhenius bases are all weak bases. So they, again, they don't just dissociate, they react with water. And when they react with water, opposite to what the acids do, instead of donating hydrogen to water, they take the hydrogen away from water to leave water as the hydroxide ion, and in this case, an ammonium ion would also be produced when the H goes over to the NH3. Okay? Anions, again, are things like carbonates. Carbonates will react with water, taking the hydrogen away from water because it has a negative charge. So that can attract, again, the hydrogen comes with a +1 charge with it. So water is left again as hydroxide and HCO3 -1. We talked in the lesson yesterday about how those charges change. When you gain a hydrogen, it increases the charge by 1. Okay, so these are weak bases. They are producing hydroxide, but they're only slightly producing hydroxide. they will conduct a lot less than a strong base would, and their pH is also going to be only slightly greater than 7. Okay, so when you're looking at your pH scale, 7 is neutral. Everything below 7 is an acid. Everything above 7 is a base. But the further you get away from 7, the stronger they become. Acids and bases, when they're strong, are both very corrosive. They're both very conductive. Okay, they're both very reactive. All right. So that is it for identifying the difference between a strong and weak acid and base and their properties. Thank you very much for watching.